This is the third in a series called Life in Earth, which seeks to examine life under our feet. The first presentation looked at the key creatures that create this underground cities and the web of life therein. The second looked a long way back to how soils actually evolved. They didn't just arrive like manna from heaven, but over a period of about 100 million years developed, and we do that in about 10 minutes. This third in the series is called Soils and Sequestration and looks more carefully at the role that soils can play in perhaps saving the damage we're doing to this planet at the moment. So the main thrust of the talk is soils and global warming. Simply, carbon in the soils is equivalent to all the carbon in the atmosphere and the vegetation together. So when we hear all the talks about the COP and whatever, I'm always listening out to hear how much is about soils. And it's only relatively in the last 5 years that the role of soils and carbon has come to the fore, and they call it soil carbon sequestration. Nice posh word. And that means the carbon is where the carbon is taken out of the atmosphere and held in the soil. And if you remember earlier on, I said all plant carbon either ends up in the air or in the soil. So quite simply, people are talking about trying to hold more carbon in the soil. And the classic calculation is that since the agricultural industrial revolution 150 years ago, we've lost something 50 to 100 gigatons of carbon from the soil into the atmosphere by the various techniques of ploughing and fertilizing and herbicides and all that lot. They help with basically releasing carbon rather than holding carbon. So people say, well, actually, those sorts of numbers, if we could get that sort of carbon back into the soil, a lot of our problems of global warming would be satisfied. In other words, this is one of the few places where we can pull in carbon rather than emit carbon. So it's a massively important area. And that's due to we've lost all the lots of plant roots, and the residues have not gone back to the soil, the ploughing, etc., and increased soil erosion, which I'll come back to. So returning carbon back to the soil is very attractive and probably the only way of actually mitigating the amount we're emitting. But to do that, we'd need every country in the world to, change their soil practices, and the likelihood of that is not high, is it? So there is an international campaign called 4 in 1,000, which aims to get each country to increase the amount of carbon in their soils by 0.4% per year, which doesn't sound very much, but that's defying the wit of our government at the moment, because while it's signed up to it, I can't see any sign of it happening at all. We can come back to that in a minute. So what I prefer to concentrate on when talking about soil carbon is talk about soil carbon in life. That is not dead lumps of carbon we're talking about. We're actually talking about carbon in life. And I saw James Lovelock speak once, and he was the Gaia theory man, and he was asked what did he think of the global warming modelling, and he said, well, it's quite good on chemistry and physics, but doesn't include biology, which was the point I was just making to Camilla. And that would include all the soils. And you've got people being a bit hesitant. The IPCC have always said, well, the trouble with global warming, as the soil warms up, you're going to get more microbes, and they're going to release more carbon dioxide into the atmosphere. So, it's all a bit iffy. And then a couple of years ago, a fabulously simple little experiment was carried out using wood lice. And they found that if you have wood lice in the system, those boring little things which we notice every time we pick up a bit of debris in the garden, what they're doing is eating the bacteria. So the carbon which would have gone into the atmosphere from the bacteria is now ending up in the woodlice. And when you've got woodlice, of course, you've got birds coming and eating them. And so the carbon is held in life. And I like that idea much more, that, you know, the carbon we're talking about is actually running around in the soil, isn't lumps of biochar. So that the carbon is trapped in the creatures as sugars, exudates in the roots, skeletons, the chitin, the lignin, and even in the gut contents. There's carbon in all that lot. So the more life we have, the more carbon we're keeping in the soil. And just to throw up, you know, again, I can come back to this, is methane. We hear an awful lot about methane as one of the main worries with global warming. In fact, if the cows are belching near the grass, there are things called hydroxy radicals in the grass and in the bacteria, and they bombard the methane and break it down relatively quickly. So if you've got cows out on grass, the methane is much less of a problem than the cattle in the stores and in the barns in intensive production. So I'm just sort of throwing up we need to bring life into these equations, not just chemistry. But this is the big one. Excuse me. Do you remember I said about those aggregates that how important they are for holding water? Well, it's something like 90% of the heat exchange of the earth is through water. The volumes of water moving around are massive, and they're not really included in the modelling. You know, it's too complicated, it's too difficult. You know, we couldn't possibly have an effect on the water. But just think about the number of global warming events that involve water. And so the soil has a very important role to play in that. Do you remember those aggregates? The macro aggregates have larger holes to hold water. The smaller aggregates have smaller holes and hold the water tighter. The soil tensions are much tighter. So between the two, these aggregates are massively important in holding water. And we can do quick experiments, you know, to show how much different soils hold different amounts of water. But it's those aggregates which provide the dual function of A, letting the water go for the roots, and B, holding on to the water for the creatures, and holding on to the water so it doesn't run off. So those soil aggregates are vital in controlling our water circulation much more. Also, and this is where the deserts are going to come into that question a while back, the plants pull in the water from the soil, goes up the stems, and the water transpires from the leaves. When that's happening, the temperature never gets more than about 20 degrees. If there's no trees and the soil is broken down and is desert, those temperatures get to 60 degrees centigrade. So I can't help but think that has a massive effect on global warming. And I was able to ask somebody, a fabulous guy called Tony Allen, he just died a couple of weeks ago, and just before, he pointed me in the direction of how to calculate the amount of heat generated from the Sahara Desert as it is now compared to what it would be with Savannah. But I'm going to come back to that in a minute. Because back to the effect of soils and holding water, I wanted to put this picture up as big as possible and for you to just really pause and look at this. This is us after the rain, after a rain. Look at the East Coast. Look at the amount of silt going into the North Sea, hundreds of miles. It's a lighter coloured soil, isn't it? Because that's coming from our best land, our grade 1 land and our grade 2 land. On the other side of the country, you can see the silt coming down basically off the moors and off the poorer land, darker brown colour, and we're losing about 1 million tonnes on that side of the land. And what are we doing about it? Absolutely nothing. The National Capital Committee produced a report just 5 or 6 months ago, and they said the state of our soil is in the red and getting worse. They were responding to the government's 25-year environment plan, which says we're going to make our soil sustainable by 2030, but nobody has any idea how to do it. There's no incentives, there's no laws, there's no regulations, there's nothing happening. And the National Capital Committee said, we currently lack sufficient data to know how badly our soil has been affected. And I'm shaking my head in horror at this. Years ago, we used to have soil surveys every 5 years, I think they were, and we could see the state of the soils. We can't anymore. We just don't have that facility anymore. And they're saying, you know, that's what we should do. And it seems to me the least we could do is to know how badly our soils have been affected. In other words, there's a lot of talk about soil health, but no action at all. So I want to set up a campaign, and there's a link to the whole presentation, by the way, in the chat line, and where you can pick up the link to this on my website. But it's to save our arable soils. So I'm hoping I'm talking with the right people about this, because when we change land use, that's from forest to pasture, from pasture to arable, we lose about half the soil life in each stage. Pastures have about half the soil life of forests. Arable land have about half the soil life of pasture. So the significant loss of our soils is from arable lands in East England. And when I say over the last 30 years, something called a countryside survey found the significant losses of carbon both in the 90s and the noughties during that period, both periods. So we've lost an enormous amount of fertile topsoils over the last 150 years. But why is that? How is that occurring? And the big problems are compaction and water runoff, which leads to erosion. So we're taking away more of the carbon. As we increase the crops, we're taking more of that yield away and not replacing it on the soil. So most fertile topsoils in the east of England could be lost within a generation, says the head of the Climate Change Committee. A generation. Not long, is it? But as I say, nothing's been done. And in the last few months, one of the few bits of law that the EU, that lot, imposed on us was something called an ecological focus area. So if you're an arable farmer with over, I think it's about 75 hectares, 5% of your land had to be given over to putting in hedgerows, trees, cover crops, rotation, nothing drastic. But the government has got rid of even that requirement. So arable farmers don't even have to put 5% of their land into any regenerative sort of practices. So I've calculated on that page that, bearing in mind the amount of energy used in making fertilizers, and then when your fertilizers go on the ground, the nitrous oxides coming off, if you calculate those both, then the amount of fertilizer being used on those arable lands in eastern England is at 2 to 4% of all UK carbon emissions. And I don't hear anybody talking about it whatsoever. I'd like somebody to challenge my figures that that's a job DEFRA should be doing, but it's not. It's completely ignored. So, back to the Sahara, the desert. Somebody asked me about a desert. Right? So what's going on? Oh, yeah, what's going on in the East has gone on in the past. And there's a fabulous book called Dirt, The Erosion of Civilizations. I'm leaving a link on it, by David Montgomery, where he tracks what went on in various civilizations, the Greeks, the Romans, the Mayans, Those three I'm picking out particularly because they all involved the same problem, and that was growing grain leading to erosion, and eventually leading to the erosion of their civilizations. So the Romans started growing grain right across Italy. They started on the valleys and then they went up the hills, and that's how they fed Rome until the yield started dropping. So off they went and colonized the Middle East and did the same there, and then went round to North Africa and did the same there. And so grain was being grown in North Africa, which has previously been savanna, to feed Rome. All roads lead to Rome and all that. And apparently it was to keep the natives quiet, to provide free food. So North Africa was used as the grain basket for Rome. And it was during that time that, again, the erosion sets in and starts the wrecking of the land. Not all, I can't blame Rome for it all, because Arab tribes came in afterwards and with the goats and completely wrecked it. But it was something in my youth 50 odd years ago that really struck me at the time, was that the Sahara is not a natural phenomenon. It is, and I'm going to say man-made because it is man-made. And I've flown over it. It goes on 3 hours and you just look down and there's just sand and rocks. And you think that should be a living being, that should be alive. And so a guy called Bob Baker, I just used to read avidly. He was called the Tree Man. And he was trying to get tree growing in the Sahara. And I can still see to this day a science magazine saying the United Nations could be doing two things. We could be looking towards building a machine that could send particles around so fast we could find out how life began. And that is now called the Hadron Collider. We built that. And on another side of the page, it said, if we all got together, we could reforest the Sahara and bring life back to it and bring people, give them a living. And I'm thinking today, that man, Bob Baker, even 50 years later, the UN hadn't picked up that challenge. So we've got a whole area of the world where the temperatures exceed 60 degrees C, and that could be down to 20 degrees C. And I keep thinking that would do a lot more than, you know, storing a bit of carbon in the soil. And just to, and the Greek and the Mayan civilizations the same. Okay, while the grain is growing on the valleys, soon as you start going up the hills, the erosion kicks in, washes it down, and the silt forms, and out it goes to the sea. And you know, I'm noticing that in this country, just in the last month or so. Where I run, one of these great big barns and cattle things, they've taken the pasture out wheat right on the side of the river. I can almost see the sand coming off there now within a year. Over towards Skipton, wheat on the hills. And then I was talking to somebody and he said he'd seen wheat being grown nearly onto the moors around Durham. And I'm thinking, this is exactly what we don't want to be doing. This is the last thing we want to be doing. So I leave that bit. What have the Romans ever done for us, as they say? Well, they've created the desert, right? So I'm going to just turn it around a bit, look forward what we can do rather than just what we can't do. Obviously, you've all got to sign up to the new master's degree at Schumacher College, which I wrote, called Regenerative Farming, Food and Enterprise. And there, the course starts with soil life. It's all about the soil. Let's understand the soil. Then if we appreciate how the soil works, then we might be more inclined to do more about it. Bring in these regenerative practices, you know, no till, no ploughing, use cover crops, use your grazing carefully, bring your animals in properly, and increase biodiversity. And somebody pointed out, you might think that's new, Charlie, but there's some people in the world have been doing that for hundreds of years. It's not new, you know, it's just we've forgotten it. But the key thing is to keep the soil covered, and that regenerates the soil. And hopefully in the regeneration of the soil, we can regenerate local economics, and that brings in circular economies and all that sort of thing. Right. Right. So I'll just finish that. with some soil solutions. The practical stuff is, which I suspect we'll have the main conversation with the growers about, is bringing cover crops. You can grow wheat with cover crops. Don't plough, no till. Use rotations more. We've lost the notion of rotations. Bring in more mixed farming, animals and plants together. We've lost that. It's plants on one side of the country and animals on the other. We should have more mixed farms like they do in Northern Ireland. Let's find ways to value soil health more and reward people for good soil health. I don't think anybody's really got any idea how to do it. With the one thought which I still have in my mind from all those years ago, but is really reinforced, is why don't we have a massive international coalition to regenerate the Sahara? Obviously, it would bring a lot of peace to that part of the world. And every night, what do we see? People jumping into the Mediterranean to get away from it. And it would cool the world down at the same time, and so save the rest of us. So I'd like to leave you with that thought and take the questions from there. A group of like-minded people like us could meet up on Zoom once a month to share ideas. It wouldn't be a bad start. I mean, because there's so much to go at. Follow up this talk. The best book is David Montgomery's Dirt, The Erosion of Civilizations, where he shows how we have damaged the soil in the past in Roman civilizations, Greek, Mayan, and we seem to be taking no notice of what's gone on in the past and how this could affect the future. For how the water influences what's going on climatically and the role of soils with water, there's nowhere better than Walter Yearn's Climate Solutions for a Blue Planet. It's on YouTube and it's a fabulous watch. The other area you might want to follow up on is the new master's degree I've written for Schumacher College called Regenerative Food and Farming and Enterprise, and has recently been approved by Plymouth University, and I'm now developing the learning materials against that. So if you're interested in following up that would be excellent. This has been the final talk in a series of 3 called Life in Earth. The first explained how the soil functions and what the creatures do to create that magnificent world beneath our feet. The second had a look at how soils were formed, and they didn't just arrive overnight, but took about 100 million years of evolution, and we covered that in about 10 minutes. And the whole show with questions can be seen if you go onto YouTube and look at Sheffield Field of Wheat. You'll see the original show there. And I wish you all the best in following up this vitally important area of bringing life to the soils, and that helping us survive more.